Hello dear friends, welcome to my class on Euler's formula in fluid mechanics. Let us see what is the statement of Euler's formula or Euler's formula. It states that dj by dt is equal to j divergence of the vector v. Here j denotes the Jacobian of the transformation or the motion of the continuum. D by dt denotes the material time derivative, and the vector v denotes the velocity of the continuum. Okay, we have to derive this dj by dt equal to j into divergence of the velocity v. The proof is very simple. Okay, let xi naught I equal to 1, 2, 3 be the material coordinates and xi I equal to 1, 2, 3 be the spatial coordinates of the same material point of the moving continuum. Okay, so xi naught denote the material coordinates. What is the meaning of material coordinates? It denotes that it is at time t equal to 0, that is before the start of the motion. Now I equal to, now at some time t greater than 0, then xi will be the spatial coordinates or the current coordinates. Okay, now, so we have to prove dj by dt is equal to j into dv. So we have taken a continuum, we have taken a moving continuum, and where xi naught denote the material coordinates and xi denote the spatial coordinates. Okay, now by the definition of the Jacobian, j is nothing but determinant of dou I dou xi by dou xj naught. Determinant of the differentiation of the current coordinates with respect to the material coordinates. Differentiation, right, of spatial coordinates with respect to material coordinates. Determinant of that matrix. So j is nothing but dou x1 by dou x1 naught, dou x1 by dou x2 naught, dou x1 by dou x3 naught. That is the first row. Second row is differentiation of x2 with respect to x1 naught, x2 with respect to x2 naught, x2 with respect to x3 naught. Similarly, the last row will be differentiation of x3 with respect to x1 naught, x2 naught, then x3 naught. By tensor analysis, we know that determinant of any tensor of order 2 aij is nothing but equal to epsilon pqr a1p a2q a3r, where epsilon pqr is nothing but the permutation symbol. Remember, we have done in our tensor analysis class. So now determinant of aij is this. Now I have determinant of dou xi by dou xj naught, right? So I rewrite that j is equal to determinant of dou xi by dou xj naught. Here I am not writing xj naught in the denominator. That is just by convention. Okay, and what is determinant of aij? Using this formula, epsilon pqr a1p a2q a3r. Now in the place of aij we have dou xi by dou xj, right? So that is equal to epsilon pqr. Okay, so in the place of a1p I should have, see, dou x1 dou xp, dou x2 dou xq, dou x3 dou xr, right? In the place of 1, p, 2, q, 3r in this formula. Using this formula, we get, this j equal to epsilon pqr like this. Fine. Now, so this is j equal to, right? Now, in order to derive Euler's formula, I need d by dt of j, right? So this is our j. This is our j equal to. Now I should take d by dt on both sides. taking material time derivative on both sides. So that means what? dj by dt is equal to d by dt of RHS. RHS is epsilon PQR, dou x1 by dou xp, dou x2, dou xq, dou x3 with respect to dou xr. Fine. So capital D by dt of this whole thing. Okay. So now we have to differentiate this now. What is our epsilon PQR? Epsilon PQR is just a number, right? So that can be taken outside. It's a constant. We can take that constant outside the derivative d by dt. So d by dt of this, three things. Dou x1 by dou xp, dou x2 by dou xq, dou x3 by dou x3. So we have three functions. So differentiation of three functions, the product of three functions. So we are going to use product rule, right? So it is like this. So epsilon PQR outside. So differentiation of the first function, the next two functions as it is. Next differentiation of the second one, the first and the third as it is. Differentiation of the third one, the first and the second one as it is, right? Using the product rule. Understood? Now next, we'll interchange the derivatives. We have d by dt or and dou by dou xp. So interchanging these two. So first dou by dou xp outside, dou by dou xp outside. Okay. Then we have so dou by dou xp outside. Then d by dt is gone inside. So interchanging these two. Fine. Okay. So dx1 by dt. The remaining two terms as it is, no change. Similarly, this d by dt and dou by dou xq will interchange. So dou by dou xq outside, d by dt has gone inside. Similarly, in the last term, dou by dou xr outside and d by dt inside. Interchanging the derivatives. We can do that, no? Because when you interchange the derivatives, the respective value remains the same. The remaining all are same. Remaining all are same. So that is equal to now, what is dx1 by dt, this term? Dx1 by dt is nothing but the velocity v1. Similarly, dx by dt is not dx2 by dt is nothing but the second component v2. And dx3 by dt is nothing but the third component of the velocity v3. We will just substitute now. See, v1, v2 and v3 by the definition of the velocity. Right? Now, in the next step, what do we do is, here I have xp, right? So what do? We'll just multiply and divide by dou x1. So dou x1 divide and multiply by dou x1. All the remaining are same, the first term. Similarly, in the second term, what do? Here we have dou x cube, right? So what do? We'll just multiply and divide by dou x2 and dou x2. All the remaining are same. Similarly, the last term, we'll just divide and multiply by what? Dou x3 and dou x3. All the remaining terms are same. Right? Now watch the terms. So we have dou v1 by dou x1, dou v2 by dou x2, dou v3 by dou x3. Look at the remaining terms. Dou x1 by dou xp, dou x2 by dou xq, dou x3 by dou x3. Dou x1 by dou xp, dou x2 by dou xq, dou x3 by dou xr. So all the remaining terms are same. So take the common term outside. So epsilon PQR is already outside. And we have, see, dou x1 by dou xp, dou x2 by dou xq, dou x3 by dou xr outside. Remaining dou x1 by dou v1 by dou x1 plus dou v2 by dou x2, dou v3 by dou x3. And this part is nothing but the gradient of, the divergence of the velocity. So del dot V. That is nothing but the divergence of the velocity, del dot V. Right? And what is the remaining term? Epsilon PQR, dou x1 by dou xp, dou x2 by dou xq, dou x3 by dou xr. That's nothing but J. Remember, we substituted in the beginning. That is nothing but J. And divergence we have written in words, divergence of the velocity vector V. And what is our LHS? LHS is dj by dt. And this is nothing but the Euler's formula. Fine. Now let us see the Euler's formula in the alternate form. We'll divide by j on both sides. We'll divide by j on both sides. See, just take the divide by g, dividing j on both sides. So what's happening? On the RHS, j is gone, and on the LHS, j has come in the denominator, right? And this LHS, we can write it as d by dt of log of j, that is equal to divergence of v. And this is the alternate formula of Euler's formula, alternate form of Euler's formula. Okay, guys, so let's stop here. This completes Euler's formula. Very, very important formula. Whenever there is a continuum is moving, this Euler's formula is applied. Okay, let's stop now. Next class, let us do some problems based on velocity and acceleration. Thank you.